So we're on page 5 of the practice exam. The osmolarity inside red blood cells is 0.30 osmolar. If the red blood cells were placed in a 0.6 osmolar solution, the red blood cells would do what? Now, because the solution that the cells are placed in is more salty or more concentrated in terms of the osmolarity, water would want to flow out of the red blood cells and into the solution. And therefore, the cells themselves, because water's flowing out, would shrivel. Okay, you just got to pay attention to what direction the water is going to be traveling. It's going to want to go from the less salty side to the more salty side. And then this question starts off the same. It's still 0.3 osmolar inside the red blood cell and then placed in the same concentration. This solution would be called, the solution itself would be called hypertonic because it's more salty, so to speak, than the red blood cell itself. Let's see. So this question, 0.1 molar solutions were made for calcium chloride, aluminum nitrate, and KBr. Which of these solutions would have the highest or least negative freezing point? See the equations page of how these dissociate. Now, calcium chloride splits into 3 things. This one splits into 4 things, and then this one splits into 2 things. So this one's going to have absolutely the lowest freezing point because that has the strongest effects because it splits into 4 pieces. So therefore, the highest melting point is going to be the KBr because its osmolarity is the smallest, and therefore it's the weakest effect. Okay, so I don't know if I'm going to be able to answer this question. Yeah, I think so. It was kind of far down on the screen here. 0.1 molar solutions were made for all 3 of these things again. Which of these solutions would have the lowest vapor pressure if they were all at the same temperature? The lowest vapor pressure is going to be the one with the highest osmolarity, which is this one for sure. Okay, because this one splits into 4 pieces, it's got the highest osmolarity, therefore the lowest vapor pressure of all of them. Okay, so that's it for the ones I can answer here. I'm going to have to scroll down now at this point. Okay, the last question on this page, page 5, is a dilution question. And as soon as I see the word dilution, I'm already thinking about the dilution equation. This is one of those scenarios where it's you don't really want to use dimensional analysis. You could do it, but it's just going to be extra work. And we're just going to plug in the values and solve for what we need. So 20 milliliters of 18 molar hydrochloric is obtained and diluted with water to a total volume. What's the final molar concentration, essentially? So what we're looking for is C2 in this case. I'm going to prearrange the equation to isolate C2, which is what we want, equals C1 V1 over V2 equals, and then we're going to plug in the initial concentration, 18 molar, times V1 is 20 milliliters. So we took 20 milliliters of 18 molar, which is super concentrated, and diluted down to 1,000 milliliters. And now we just calculate this and see what we get. Okay, so the final concentration after dilution with 3,6-phixamine, capital M, 0.360 molar HCl. And that makes sense because its concentration is way lower than what we started with. Okay, so that's it for page 5. Pretty simple page.